question, we are given a symmetric matrix which is on the left hand side of the equation and asked for what lower triangular decomposition in its lower triangular decomposition, how many elements will be purely real. Underneath the question, you can find the title of an NPTEL course which relates to the topic. The only background that you will need to know for this problem is the definition of a lower triangular matrix. That is a matrix whose elements above the main diagonal are zero. That is only the elements that are on or below the main diagonal can be possibly non-zero. But every element above the main diagonal, that is whose column index j is greater than I, is guaranteed to be zero in a lower triangular matrix. So in this question, we are asked how many purely real elements are there in the lower triangular representation of the given 3x3 matrix. So you can see that they are trying to decompose the matrix 3x3 matrix into a lower triangle representation. So this is a lower triangular matrix, which is to say that every element that is above the main diagonal, that is every element that's above the main diagonal corresponds to obviously the a11, a22, a33 elements, is a zero. So if there are any non-zero elements, they will be on the main diagonal or below it, hence lower triangular. So a lower triangular representation corresponds to triangle into triangle transpose, where triangle is a lower triangular matrix, right? So the elements that are definitely zero are these, and the elements that could potentially be non-zero but are not guaranteed to be non-zero are these, right? So that's a little background on lower triangular matrices. Now let's go to solving the problem. So it's fairly straightforward. At first you take the decomposition and then perform the matrix product, which will end up in a single matrix which looks like this, and then equate the elements on the left with the corresponding elements in the matrix positions on the right to obtain 9 equations as such, right? There are 9 equations here, but since this matrix is symmetric, that is the element over here is the same as the element over here, and the element over here is the same as the element over here, and so too over here and here, you will see that 1 and 2 equations are actually duplicate, right? You are seeing a duplicate equation here, and actually there'll be another duplicate here corresponding to this pair, right? So there are 3 duplicate equations which we can omit, right? So omitting duplicate equations and actually solving it, for instance, a1 square is equal to 2, so a11 square is equal to 2, so a1 is plus or minus root 2. So on and so forth. We then substitute the value of a1 into these 2 equations to get a12 and a13. We substitute the value of a12 here to get a22, and so on and so forth, where we keep substituting values that we found before to get the next values. You would find that the lower triangular representation of the matrix corresponds to the following matrix here. It just so happens to be that every lower triangular element and the main diagonal element is non-zero, but there are notably 2 complex elements. So counting the zeros, that is counting these elements which are also real, there are 7 purely real elements, that is 9 minus 2, 7 purely real elements in the lower diagonal matrix. You will notice that 7 is not an option here, and in fact this question, which is from GATE 2020 doubly paper, has been given the marks have been awarded for this question to everyone that had attempted it, because the correct answer is not mentioned in these options.